Hello and welcome to this tutorial. So from today onwards, we are going to start a new series that would be based on Apache Spark plus PySpark. So we will start from basics from Spark core and we will discuss everything about PySpark. In this, we will discuss the programming part of PySpark as well as the theory part of PySpark. So let's get started. If I talk about the Apache Spark, so it is a general purpose in memory compute process engine for parallel processing in distributed environment. So do not worry about this definition, just think of that we know what is parallel processing and what is distributed file system. Okay, so in my big data playlist, I have discussed everything about all these things. So just compare this with those Hadoop technology, like how Hadoop was working and how storage part of Hadoop was working and how the processing part of Hadoop was working. So then we will understand what exactly the Apache Spark is. So if I talk about the differences between Hadoop and Spark, so Hadoop was only able to process the batch data. So as I discussed, if there is any batch activity, day end activity or midday activity on a daily basis, so that is something which is known as batch data. But in case of Spark, we can process batch data as well as the real time data. So how we can do this real time data processing using Spark streaming, we will see in upcoming topics. Slower processing speed. So this was the major problem with Hadoop, where it was using MapReduce and it was using Java programming language. So that is why it was taking inputs in form of key value pairs. So that is why it was highly slow. Comes with inbuilt cluster resource manager. So as we discussed in Hadoop, there was one inbuilt resource manager that was known as Yarn. But in case of this Spark, we do not have any inbuilt cluster resource manager, but here we need to plug in the cluster. Like you have many choices, either you can use Yarn, either you can use any other thing. Okay, so this is something which differs from Hadoop. Totally dependent on HDFS, local file or cloud storage. So if we talk about the storage part, so Hadoop was totally dependent on HDFS and local file system or cloud storage. But in Spark, again, we have many options. Either we can use HDFS, either we can use local file system, or we can use many things like Apache Kafka, HBase, Cassandra and streaming also. So this is something which is going to add some feature in Spark. Less inbuilt functions available in MapReduce. So if you're a developer and if you are going to write a code, then obviously in Spark you have options to write your code in either in Python, in Scala or Java, but there are many inbuilt functions available. So if I specifically talk about the PySpark, in PySpark we have many functions, inbuilt functions to use and to perform all the activities. Now let's come to this point. So this is something which I am revising from my previous tutorial. Whenever we talk about Hadoop, we say Hadoop provides generally three things. One is HDFS, that is for storage. So we have only one option, HDFS, second option local file system. And if we talk about the processing part of Hadoop, so we have only one option, that is MapReduce. Third thing, that is resource manager, we have Yarn. Okay, so Hadoop seems little like congested with all these very less options, but if we talk about Spark, we have many options, many storage options, we have many processing options, we have many resource manager options. Okay, so this is something which is very important. We cannot say Spark replaces Hadoop. As I discussed, Hadoop has three parts, so we cannot say Spark is going to replace Hadoop. Spark only replaces a part of Hadoop, that is MapReduce. So the processing part of Hadoop, that whatever it was, will be replaced by Spark. So Spark only replaces the processing part of Hadoop, that was MapReduce. Yes, we can say Spark is an alternative of MapReduce. So Spark is not an alternative of Hadoop, it is an alternative of MapReduce. Okay. Now let's deep dive into the definition of Apache Spark. Apache Spark is a distributed general purpose in-memory compute engine. So now instead of compute engine, we can say distributed data processing engine. So I told you, like if we have file, we can make blocks of that file and we can pass those blocks to multiple nodes or machines, and those multiple nodes or machine will do data processing in parallel fashion. So that was something which we say distributed data processing. So let's understand each and everything, like what this definition says. First thing is compute engine which performs data processing or data transformation. Now second thing and very important thing, in memory computation. Although we are going to discuss this in memory and on disk operations in detail, like how these things internally work, but so in memory is something. To understand this in memory, let's compare this with MapReduce. So as I said, Spark is an alternative of MapReduce, so we are going to compare Spark with Hadoop here. If we are doing any job in MapReduce, it will not be a single MapReduce job, but rather it will be a chain of MapReduce jobs. Like how exactly this works? So let's think of 5 MapReduce jobs with HDFS as of now. So we have MapReduce job 1, we have MapReduce job 2, we have MapReduce job 3, we have MapReduce job 4, we have MapReduce job 5. Now we are talking about the HDFS. So guys, please remember HDFS was something which we were saying the storage part of Hadoop. So this is the storage part of Hadoop. Like initially we are storing our big data in HDFS. Okay, now what will happen if we have multiple MapReduce jobs? One MapReduce job will gets divided into multiple MapReduce jobs. So let's think here we have 5 MapReduce jobs. So MapReduce one job will take the input from HDFS. So this MR1 job will take the input from HDFS. So it is taking the input from HDFS. So disk access is required. Please remember, disk access is required. Like MapReduce 1 will require the disk access from the HDFS. So HDFS is somehow we can say disk storage. So disk access is required to take data from HDFS, and then it will process the particular data. After processing, MapReduce 1 process result will be sent to HDFS. Now one job performed. At the time when MapReduce one job was getting data from HDFS, it requires disk access, and then after processing it is sending the data back to HDFS. Now MapReduce 2 will take the output of MapReduce 1. So now MapReduce 1 process output, where it is in HDFS. So MapReduce 2 job will take the MapReduce 1 process output from HDFS. In that case also it will require the disk access because it is taking the data from disk. Now again MapReduce 2 will process the data and it will send the processed MapReduce 2 data to the HDFS again. So this process will happen in each and every MapReduce job. So like this process will repeat for each job. Okay, it summarizes for every MapReduce job it requires 2 disk access, one for accessing the data, and after processing it is writing the data back in HDFS. So it requires 2 disk access in each and every MapReduce job. So we can say if we have 5 MapReduce jobs, then we require 10 disk accesses. This was the major problem with MapReduce. Okay, how Spark solved this problem? Now Spark is something which solves this problem. Spark says I will load the data initially in B1. It can be anything, like we are saying instead of MR1 we are saying here B1, which is in memory. We will do processing and write the data in V2, which will also be in memory. So let's understand the process of this Spark, how Spark is different from the MapReduce. So in case of MapReduce, what we were doing, we were taking the data from disk and then we were performing one operation, then we are writing the data back to HDFS, and then we were reading the data from disk. So the third disk access is required. Then we are, so here we are, if we talk about this simple processing, we are doing simple processing and we require 4 disk access. Now let's understand this Spark processing, how Spark will work here. So what Spark will do, it will initially pick the data from HDFS. So in that scenario, it requires disk access. Now what it will do, it will put all the data in RAM. It will put all the data in memory instead of disk. It will put all the data in memory instead of disk. So it will process the data, and once the processing of data will be done, then only it will write the data to HDFS. So it seems like for 5 MapReduce jobs we require 10 disk access, but for 5 MapReduce job, or we can say 5 jobs, 5 Spark jobs, we require only 2 disk access initially for reading the data, and after performing all the operations for writing the data. So this was the major difference between Spark and MapReduce. So this is how we say it is in memory computation. Spark is in memory computation because all the operations, medium operations, will happen in memory instead of disk. It states that most of the data is always in memory. This is why Spark is said to be 10 to 100 times faster than MapReduce. I hope you understood the difference between MapReduce and Spark, how this Spark, why and how this Spark is 100 times, 10 to 100 times faster than MapReduce. Now third thing is general purpose. General purpose is something, it can be used with multiple purposes. If we compare with Hadoop, here for data cleaning we have Pig, for querying data we have Hive, for ML we have Mahot, but Spark is something, Spark has all the features. So if we talk about the Spark, for compute engine we have Spark, and for storage we have many options. We have cloud, Amazon S3, we have HDFS, we have local file system. In resource manager also we have multiple options. We can use Yarn, we can use Mesos, we can use Kubernetes. But in case of Hadoop, what it was in case of MapReduce, or in case of Hadoop, we were having only one option to use the Yarn only, because that was inbuilt in that case. So that is why we say Spark is a plug and play compute engine which need two things to work. So any storage and any resource manager. So Spark says I am not bound to any single type of storage. As in case of Hadoop, when we were using MapReduce, we were bound to only HDFS, or we were bound to only local file system. But Spark says I am not bound to any single type of storage. You have many options. You have multiple options. Also, I'm doing in-memory computation. So that's why I am very fast. So that was the introduction about the Spark. In further tutorials, we will discuss more about this Spark, how Spark work, and we will move to PySpark and coding part of PySpark. So that was all about the Spark basics. Thank you so much. Bye bye.